So if we do anything like on a test or quiz, I will give you that little, I have the little picture on the quizzes and tests so you can reference it. But I just want to give you an example of each one of these really quickly, just really basic. So that end behavior is completely based on what we call the leading term or the first term in your polynomial. So your first term is going to tell you two things. The degree, which is just your exponent. So like x to the third is a third degree or a cubic. We talked about those names. And then whether or not that leading coefficient has a negative in front of it or not, so whether it's positive or negative, that's going to split into all the possible categories. Okay, so I'm just going to give you the most basic one I can think of for each. So let's say I literally just asked you to graph the line y equals x. Just y equals x, okay? That would be considered positive because it's just a plain x. There's no negative in front of it, anything like that. The exponent here would likely not be written into that, but it would just be x to the first. So this would be odd. So this is the most basic positive odd function that I can think of for you. So I'm just going to sketch like a little picture. So here would be like an x and y axis. Okay, so if I graph this, right, just y equals x, your y-intercept would be 0, and you'd just go like up 1 over 1, up 1 over 1. So just as a little sketch, it would just be a perfect diagonal line right through the origin there. And what I would call the end behavior is what does the graph do at the far left? What does the graph do at the far right? So if you look at this, on the far left, I'm pointed down, and on the far right, I'm pointed up. And so that goes with my positive odd, which is down at the beginning and up at the end. All right? Now, the other most basic odd that I could think of for you, if I just did y equals negative x. Okay, now, because I have a little negative in front of that, x, that's considered negative. All right, and then this is odd again, because it would just be x to the first. And if I just sketched a little picture, right, that would, same thing, y-intercept would be 0, but we would go down 1 over 1. So the slope would be negative here. And so the graph would look something like that for a sketch. Now, if I'm negative and odd, my end behavior, it actually goes up to the left and down to the right. So that's what you have in this little chart, up to the left, down to the right for your end behavior. Another good way to remember this, if you have an odd function of any kind, odd polynomial, the end behavior opposites. They always go opposite directions when you're odd. Okay, now the other two possibilities are when your degree is even. So just the most basic I could think of, let's just do y equals x squared, right? We just got done doing quadratics, so I know you guys remember how to do this. I hope you remember how to do this. So this would just be 0, 0 would be my vertex there, and I'm just going to kind of sketch a picture of a parabola. Hopefully that looks decent. But what you will hopefully remember is both ends of this would point up. And I totally didn't write this out, but this would be considered positive because I just have an x squared. There's nothing negative in front of it. And then this is even because it's x squared. So the end behavior there, positive, even, both ends are going to go up. All right, and then the final option here would be negative and even. So just the most basic version of that, I'd just write like y equals negative x squared. That's negative because I put a little negative sign there. And then it's still even because that exponent is squared. So if you guys remember, if you have your parabola and you have a negative, that just turns it upside down. So it would just look something like that. And then the end behavior, or what's going on at the end of the graph, both ends of this are pointed down. So in my little chart here, both ends of that are pointed down. So those are all the possible things that could happen when you're graphing for what the end, far left and far right, what would that look like on the graph? Okay, is anybody having a question at the moment? Okay, now we're actually going to apply this to some polynomials, so those are very basic versions. So we're going to do something that has a little bit higher power here. Okay, so I have all of these on the front in factored form to hopefully make this a little bit easier to do. The tricky part, though, is what would the leading term or what would the first term be if we multiplied this all out, because the degree and whether it's negative or positive is based on that. So I'm not asking you to do this, but if I did multiply, like FOIL this all out, Can anybody tell me what the very first term would be? If you multiplied it all out and put it in standard form, what would the first term be? X cubed. Okay, how'd you get that? Exactly. Okay, so if you just take, as long as they're written in standard form, if you just take the very first term of each of your factors, if you were to multiply that out, that would give you x times x times x. That would make it x to the third. Okay, nothing making this negative or anything like that. So this would be positive, and that x to the third would make it odd. So then, I know my end behavior has to go down at the beginning and up at the end. Now, the only other thing you got to do to put this on the graph is tell me what the zeros are. So in factored form, this is not too bad to do. So where would the graph have its zeros if you've got that lovely factored form of that? Like, where would the zeros be for this particular graph? What number? Yes, okay, so 5, 1, and -2. Okay, here's all you're going to do. Just come down to your graph, and these are just going to be a sketch. They're not going to be perfect or anything like that. I'm just looking for, do you have the correct zeros? Do you have the correct end behavior? So I'm going to put a dot. All these are on the x-axis because these are the zeros. These are x values. So -2, 1, and 5. Okay, now all you have to do for the graph, the end behavior is what I do. On the far left, whatever's on the far left, that's -2 here, I'm going to draw down. And then on the far right, I'm going to draw up. That is how my graph is supposed to end up. Now, all of these, just plain little sets of parentheses. So on each of these, we're just going to go right through the x-axis. And then I got to come back down because I got to go through the 1. And then I'm going to come back up because I got to go through the 5. And it doesn't have to be perfect or anything like that, but you're literally just going to wave through there to create your polynomial graph. And it doesn't have to be perfect. It's just a sketch. I'm just looking for, does it go through the x-axis in the correct places? Do you have the correct end behavior? Okay. If I multiplied this guy out, what would the leading term be, or the highest power of x for that factor term? What do you think? Yes, ma'am. -x cubed. Okay, so then that negative causes this to be negative. And then this is odd again. That goes up at the beginning and down at the end for your end behavior. What would my zeros be for this one? Yeah, go ahead. 0. And the negative's not going to affect that anyway. It's just going to be 0, 3, -3. So just come to your graph. -3, 0, and 3. All right, and then I just put in the end behavior. So I identified that this was negative and odd. So it should go up on the far left, down on the far right. Odd goes opposite direction, so one's up and one's down. And then you're literally just wave through here, going through your zeros. So I'm going to go through the -3, come back up, go through the 0, come back down, go through the 3. If you draw your end behavior correctly, it should force the graph to match up with what you have. And that's all I'm looking for. Does anybody have a question? Okay. What if I looked at letter C here? If I multiplied that all out, what would the first term be? If I multiplied this all out, what would my first term be? X to the 4th. All right. So nothing making that negative, so this guy's going to be positive, and then my exponent here is 4. 4 is an even number, so this is even. Okay, where are we going to go through the x-axis for this graph? Go ahead. 0, 3, -2, and 5. All right, so we'll just plot those points. Oh, sorry, positive, even. The end behavior should go up on both ends. Anytime it's even, it's like a parabola, so they go the same direction. So I'm going to do -2, 0, 3, and 5. And again, I just start and I go ahead and draw the end behavior right into the graph. I know it should go up at the left, down, or up at the left and up at the right. If it's even, they go the same direction. And then you're just going to wave through there. So go through that -2, back up through the 0. Just kind of come up. We're just kind of making it a curve, almost like a parabola. And you're going to come back down through the 3 and then come back up through the 5. Does not have to be perfect, we're just doing a sketch. All right, and I got one more. Now, this one's really tricky. So if I multiplied the first term in each of these out, which I'm not asking you to put it in standard form. Yes, negative 2x to the fourth. So you got the negative x, the 2x, the x, all the x's would give you x to the fourth. Negative 1 times 2 gives you the negative 2. So this is negative, and it's going to be even because of the 4. Okay, now, 0, right? Now, 2/5. Oh my gosh, why did I just say that? 5 over 2. So I'm going to subtract 5, divide by 2 if I set that equal to 0. Now, if this helps you guys in any way, shape, or form to kind of estimate where that should be on the graph a little bit better, it should be negative 2.5 if you take 5 divided by 2. And then, let's see, we got 4 and 2. So when you estimate, just kind of estimate the best you can between the negative 2 and the negative 3. Then you're going to go through 0, 2, and 4, and I did that again on this question. Negative and even, for my end behavior, both ends should point down. So just on the far left, whatever zero's there, go down. And then on the far right, whatever zero's there, also go down. And then we're just going to wave through this. Just kind of curve. Doesn't have to be perfect. It's just a sketch. Is anybody having a question so far? Okay. So that was just one of each type that you could have. Okay, now, I have not given you any questions like this, so we're going to see this in this example. But the multiplicities that we talked about last week are going to come into play on some of these questions on the back. Okay, if you have an even multiplicity, and I'll draw you a little example here, it creates what we call a bounce. I did not have any examples like that on the front. So a bounce means it doesn't actually go through the x-axis. It's going to bounce back where it came from. So let me just give you like the tiniest example. All right, let's say I had y equals, I don't know, I'm gonna shift it just a little bit. Let's say I had x minus 1 squared, right? So that would have a multiplicity of 2. Okay, now my leading coefficient there would be x squared, so that would be positive and even. And hopefully you guys remember from graphing our quadratics here, this would have a vertex. I don't have anything added or subtracted, so just be 1, 0 would be the vertex. Now, if I were to actually graph that, right, that's the vertex, the graph looks like this. It's a parabola. See how that doesn't go through the x-axis. Basically, you come down, you touch the 0, and then you bounce back where you came from. So we haven't had any like this, but if you ever have an even exponent on any of your factors, or we'll see this here, like I have an x squared in part B of example 2. If you have an even multiplicity, it does not go through the x-axis there, it bounces back the way that it came. Okay, now everything we did on the front, because this says includes 1, it was an odd multiplicity. So let me give you one that's a little bit of a different example. Let's say I had x minus 2 cubed. Okay, so that would be an odd multiplicity. Anything that's just a plain set of parentheses would be to the first power, so that would be odd. Anything like 3, 5, 7, if you had any of those, that is going to go ahead and it goes through the x-axis. And I know you guys aren't super familiar necessarily with cubics, but if I multiplied this all out, this would be x to the third, and so this would be positive and odd. So that would go down at the beginning and up at the end, but I'm only going to have 1, 0 here with my little example. So if I just went over to 2, this does go through the x-axis though, but it would bounce. So basically, like this end would go down, this end would go up, just as a sketch, but it goes opposite directions. Anytime it is an odd multiplicity, you go through the x-axis. If it's even like this, it creates like a little bounce, like almost like the vertex of a parabola is what it looks like. So we're going to practice this here. Okay, so I've got exponents on these factors in example 2. So, and I should have written this out here. What if I multiplied this all out here? I have x plus 1 squared and then x plus 4 cubed. what would the leading term be if we multiplied all of that out? Keeping in mind, like x plus 1 squared would be x plus 1 written twice, x plus 4 would be written out 3 times. What would your leading term be? Yes, ma'am. Okay, x to the 5th. 2 from here, 3 from here. So this is positive, and it's going to be odd. So my end behavior down at the beginning, up at the end. Now I have negative 1 as a 0, and negative 4. We only have 2. Okay, so negative 4, negative 1. All right, now I know the one to the far left, I'm going to draw down on that, and the one to the far right, I'm going to draw up on that. Now, if you do your end behavior correctly, it should kind of force you to make the graph correct. Now, here's what I do, and it's totally up to you. If I have a bounce, which I have for even multiplicity, which I would have here, I like circle, or maybe I highlight or something like that on that point that I know. Don't go through the x-axis. I want to bounce back the direction I came. All right, if you already drew your end behavior in here, you're going to go through the negative 4, and I just try my best to kind of like draw a parabola, like draw a little curve so it's kind of a U shape. So I got to come down, touch the negative 1, and then I've already drawn my end behavior in that would show it bouncing back up. So just on that negative 1, since I got an even multiplicity, I'm going to bounce back up. Okay, if I multiplied, sorry, I should have put a little space for this here. If I multiplied this all out, what would my leading term be for that next one? Yes, okay, x squared, and then another x to the 3rd, x to the 4th. So this is positive, but this one is even because I've got a 4. So positive, even, both ends of that are going to point up. All right, so I'm going to go through and check my zeros here. So I've got 0, 4, and negative 3. So I'm just going to plot those real quick. All right, and then I know it needs to go up at the beginning and up at the end because even goes the same direction, both. These are both going to go up because it's positive. Now, do I have a bounce on any of these? Which one do I have a bounce on? 0, because I know it's not like x minus something or x plus something. So this is a bounce right here because that's an even multiplicity. So I do not want to go through the x-axis there. All right, the other two both just say plain sets of parentheses. So you're going to go ahead and go through. So I'm going to go through the negative 3, and I'm just going to try my best to make a parabola here. So I'm going to come touch the 0, but I'm going to bounce back down, and then I have to come back up to go through the 4. So it would look something like that. Excuse me. Is anybody having a question? Okay. Now, my next graph. Now, this is actually super easy. My leading term, if it's in standard form, I can literally just see it because it's all multiplied out. This would be x to the 5th. So this is going to be positive and odd. So I know it's going to go down at the beginning and up at the end. My problem here, if it's in standard form, where am I, like, how do I know where it's going to touch or go through the x-axis? Like, what would you do to figure that out? So if I'm looking at this, like, how do I know where to put it on the x-axis? You have to factor it. Okay, so this is why I had you guys do that last lesson. All right, how would I factor that? Yeah. For this one up here? Or no, for x to the 5th we just did. Okay, if it's in standard form, it's all multiplied out, so it's literally just the first term. So I didn't have to like figure it out because we didn't have the factors here. So that's a little bit quicker to see because it's all multiplied out. But the problem is I don't know where to put it on the x-axis. Okay, you pull out x cubed, what would you have left? Wouldn't we have something before that?
Oh, I do have 6x. X squared.
There you go.
Negative 6x plus 9.
Perfect. Okay. Yeah, don't forget that term. Okay, everybody has at least an x to the 3rd there. Now, see if we can factor this a little bit further. what are two numbers that are going to multiply to get you 9 and add to get you -6? -3, -3. Okay, now I'm going to write this out on my paper, but if you want to skip this step, you can. Because both of the, that's one of those perfect square trinomials, because both of those factors are the same. Forgive, I'm just actually going to write it up here so I have a little more space. I can squish those two together. That'll actually be an even multiplicity. So the x minus 3 squared. Okay, so I'm only going to have 2 zeros here. All right, so 0 and then +3. Now, I know my end behavior. We're going to go down at the beginning and up at the end. Do I have a bounce? Yes, on the 3 or the 0? 3, because it's got an even multiplicity. The x by itself is just 0, so that's x to the third, so it's odd, it's going to go through. So at 0, just go ahead, go through, and then you're just going to come back and just try your best to kind of draw the vertex of a parabola. So I'm going to hit that 3, and then it's going to bounce back up. I already drew my end behavior, so it would do that. Even multiplicity, you're going to bounce. It doesn't happen on every single problem. It just kind of depends on the question. Okay, now I have one more. Now, if this is all multiplied out for you in standard form, the leading term is literally just the first term. So this is -x to the 4th. So this is negative then, and the 4th power is even. So both of those guys are going to point down. The problem is I can't see my zeros just in that format. I got to factor this. All right, so what would you maybe pull out, or how would you factor? I've got -x to the 4th plus 16x squared. What do you think? Yes, good. Okay, now you want whatever's left in your parentheses, you want that first term to be positive. So if this starts with, I would factor out like a -1 from both, and then x squared. Now left over, this will be positive x squared, and when you take out a -1 here, this will change this to -16. Okay, now, can you guys remember how to factor x squared minus 16? Yes, okay, now this is not a multiplicity here. This is a difference of squares. So x minus 4 and then x plus 4. Those are two totally different numbers. Now, your zeros here, we've got 0, we've got 4, and we've got -4. Now, those are just plain sets of parentheses on the 4 and -4, so those will go through. You do have a bounce here, because when we took out that -x squared, that squared on the x is an even multiplicity there. So at 0, I'm going to have a little bounce. Okay, so I'm going to put my -4 and my 4, my end behavior, because my leading term, -x to the 4th, both ends of this should point down. And then I'm going to go through the -4, and then just try your best here. It doesn't have to be perfect. I'm going to try and draw a parabola here. I'm going to bounce back from the 0, and then I'm going to come back down through the 4. Should look something like that. And these are not to scale, it's just a sketch. That's why I don't even have any labels on the y-axis. It is just a sketch of the graph. It's not perfect or anything. Is anybody having a question? Okay, we still got a little bit of time, don't worry. The rest of this is really fast. Okay, so there's going to be some questions that will actually just give you a graph and say what's the lowest possible degree. Easiest way I can tell you to do this is I'm going to write number of intervals of increasing or decreasing. We have not done this in a minute. We did this with parabolas back in Unit 3. We're actually going to do this with polynomials tomorrow. But number of intervals of increasing and decreasing, you're like, what the heck? I'm not asking you to write intervals. I promise this is super easy. Literally just going to come over to the graph, right? If I was tracing this graph, here I am increasing, yes? And when I get to that little top part, this is then decreasing. And then I switch back and the rest of the graph is increasing. So I colored 3 different intervals there, right? Increasing, decreasing, increasing. So the lowest possible degree here is going to be a 3rd degree. So just however many, when you switch, you're writing a new interval. I'm not asking you to write the intervals. I'm just asking for the lowest possible degree. So like if I do this one right next to this, here, increasing, then I'm decreasing, and then I am increasing, and then just for a little bit, even there's a bounce here, but that does not change how you would identify increasing, decreasing. So see, I did 4 different things with my highlighter here. So this would be lowest possible degree, this would be 4th degree, so like an x to the 4th. All right, what I'm going to ask you to do in the next page, we are just going to analyze these graphs a little bit. I promise it's not hard. It's not going to take more than about 5 minutes. All right. So I'm just going to have you look at the graph. Now, you can decide based on the end behavior if this is a positive. I'm not asking you to write it. I'm just saying, is this positive or negative for my leading coefficient? If I just look at that first graph, do you think this has a positive or negative leading coefficient? Positive. They both ends point up. If they both go up, it has to be positive. Okay. Now, if I did my little increasing, decreasing, you don't have to highlight the graph every time. How would I determine, or what would you tell me the lowest possible degree is here? Has to be an even number, right? Because they both point the same direction. Should be 4. So you're going like down, up, down, up. This is 4. All right, now your zeros, you're literally just going to pick them off the graph. So -4, -1, 3, and 6. And the last part of the question literally is just going to have us actually write out a possible equation for the polynomial in factored form. So you're just going to turn your zeros into factors. It's really quick. So if -4 is the 0, x plus 4 would be the linear factor. If -1 is my 0, it'd be x plus 1. If it's 3, it'd be x minus 3. And if it's 6, it's x minus 6. Those do not have to come in any particular order. You do not need to multiply it out. It just says factored form, and you would just leave it like that. Anybody having a question? Okay, if I ask you about the graph next to this, what do you think, positive or negative for your leading coefficient? Has to be negative, right? Okay, now, I'm just going to highlight this real quick because people screw this up when they write the equation. Okay, what would you tell me your lowest possible degree would be for this graph? 4, right? You're going up, down, so 4. All right, now my zeros, right? I've got -3, +1, and 5. And I would say, hey, at one of those there was a bounce, right? If you're looking at the graph, there is a bounce there. Okay, so just keep that in mind when we write our little factored form. Okay, now, if you have a negative leading coefficient, please don't forget to do this. This is negative. So literally, I am just going to say, let's just write a negative out in front of whatever you write down as your first factor. All right, that's it. Just put a little negative out there. Now, x plus 3, x minus 1, x minus 5. Those are all my linear factors there based on my zeros. What do I need to put into that to make that more accurate? Yes, you got to bounce. Okay, now you can literally do any even number you want. You could put a 4, you could put a 6, you could put an 8, whatever. I usually just put a 2, but if you have a bounce, you just need to put an even exponent on that factor. So it bounced at the 1, so I should have a squared or a fourth or something like that on the x minus 1. Okay, now this is completely up to you, because the odd ones are kind of tricky for people to remember. So you don't have to do this. I'm just going to grab like a weird highlighter here. Okay, if I'm trying to figure out positive or negative for an odd graph, I know these are odd because they go in behavior with opposite directions. I literally just like draw myself a little line that kind of mimics the end behavior. And then I say to myself, would that line have a positive slope or a negative slope? So if I just gave you a line like that and I said, let's find the slope, would you tell me it was positive or negative? Positive. Okay. I don't know why, but people sometimes have a hard time, but you can always do that with an odd function. Just kind of draw a line over the top that mimics the end behavior. That'll tell you whether that leading coefficient has to be positive or negative. All right, what would you tell me for the lowest possible degree here? 3. All right, now your zeros, I don't have any bounces here. This is going through -5, 0, and 2. And honestly, I don't care the order you put these in, but if 0 is one of the places the graph crosses or goes through the x-axis. Typically, you would take and put an x like out in front. You could put x minus 0 or x plus 0 if you wanted to put in parentheses, but it's just usually an x is easier to do. And then I'd have an x plus 5 and an x minus 2. I didn't have any bounces, so I didn't have to put any exponents or anything like that. All right, now kind of the same thing. If you're not sure, I just kind of draw myself like a little line over the top that mimics the end behavior. So that one goes up on the left and down on the right. So this would be negative here. Now, if it's negative, I might just immediately, so I don't forget, go down here and put like a little negative in front of my factor, so I don't forget to put that in, because that's a common thing that people will do. If it's positive, you don't have to worry about it, but if it's negative, we'd have a little negative out in front there. What do you think the lowest possible degree for this one would be? What'd you get? Fifth, right? 1, 2, 3, 4, 5 different directions there. All right, now, -4, -1, 4, and 6. And I'm seeing a bounce does not go through the x-axis at -1. So just keep that in mind when you write your factors. I'm going to write these real fast. So x plus 4, x plus 1, doesn't matter the order, x minus 4, x minus 6. I would want to see an even exponent on that x plus 1 because you've got a bounce at -1 on the graph. So just don't forget that. Does anybody have any questions? Yeah, I'll come back and get it for you.